Hello, how are you, everyone? Dear authors and invited guests, welcome to our technical session, the second one for today. It's my great pleasure to welcome you to the fifth S4 conference on smart trends in system security and sustainability through Zoom on behalf of WS4 2021 and Global Knowledge Research Foundation. We are thankful to everyone to present on this platform to go along with us with digitally and for the conference in these unpredictable circumstances of COVID-19, which for sure will not support the scientific contribution of all of the scientifics and the researchers. So thank you for everything and for making this conference more productive. Also, we wish everyone and their families are in a protected time, as well as for sure we will all together by science and research contribution pass through this unpredictable circumstances very soon. We hope you will enjoy those today's conference, which is hopefully knowledgeable and interactive, including all the sessions. And then just before we get started, we wanted to welcome our chair session for today, Professor Balbardi, and now I will introduce a very short brief about his profile, which is already rich and could not be summarized with one or two paragraphs. So Professor Baidi is the director of Center of Communication Technology Research Group. His research is in the area of microwave wireless communication, encompassing 5G mobile phones to satellite technology. Professor Vardi graduated with PSc, a bachelor degree in engineering with honors in communication engineering and MPhil from Leeds University in the UK. He obtained his PhD from the University of North London in the UK as well. He was worked as an academic in Open University and Leeds University. Prior to this, he was a research development and electronic engineer in future product department at Telendi Defense. Also, he worked as by TVT Phillips in Cambridge. So most welcome, Professor Verdi, and many thanks for your time in the session today. So thanks, sir and madam, thanks, sir, for chairing this person. And now we will start with the papers. But before that, I wanted to just remind you with some ground rules that each one of you would have 10 minutes for presentation, 2 minutes for questions. For sure, you can push any question to the chat box and I will help you to share it with the presenter after for sure taking the chair questions. I will have a friend of mine here in the session. So when you have 2 minutes left, I will raise it just as a reminder not to interrupt you while you are presenting. So please keep an eye with the time or with me, whatever would be helpful to you. And now I will start with our first presenter, Ms. Husseini from Tampere University in Finland. On behalf of the co-authors, it would be our pleasure to listen to the presentation of the paper titled as Utilizing Technology Pedagogical Content, TPC, for Designing Public Service Websites. So the floor is yours and we are all listening. Thank you for your time and presentation. Go ahead, please share your screen. I will stop the sharing from my side. Could you please just unmute yourself and go ahead. I'm sorry, you're muted, miss. Yeah, from the Zoom, there is a mic. Yeah, it's brilliant.
You have my
It's
voice now?
yeah, we can hear you clearly. Just share the screen and we are all with you. Thank you.
Yeah. Mm. Okay. Mm. Sorry. Mm.
It's fine. Yeah, this button. Or press F5, it would be easier. Yeah, it's brilliant. Go ahead. Thank you.
Something is wrong. I think it's. Sorry.
No, no, it's fine. If you need any,
Something is.
no, it's fine. It's fine.
Um, Hello, everyone. I am Zahra Hosseini from University of Tampere in Finland. The title of my presentation is utilizing technological pedagogical content, or TPC, for designing public
Sorry for
service.
interruption, but could you please just share your screen? It would be much easier,
Oh,
and you
sorry, it
yeah,
was
you will
not.
get less questions.
Uh,
It's fine. Even if it's not comfortable to make it full screen, it's fine. It will work.
you have now?
Yeah, yeah, I can see it now. Yeah, thank you.
Okay.
Yeah.
Um, um, I'm from University of Tampere in Finland. The title of my presentation is utilizing technological pedagogical content for designing public service website. Um, while organizations are investing huge amount of money for transferring valid and reliable information to their website, many users are seeking information in social media. The way that social media has become a source of information in many studies. It shows that many organization websites are not successful to meet or attract their end users. Because of the importance of government websites, the researchers tried to define criteria and models for evaluating the quality of websites. Most of the studies concluded that information on the website do not meet expectation of users. While most studies have focused on evaluating the quality of government website, in our study, we are trying to offer the instruction to create and organize the content of website. Here we introduce technological pedagogical content design, or TPCT, as a model with focus of pedagogy to create and design the content of the website. TPC, or technological pedagogical content, is a practical instruction that originated from TPAC, derived by Mishra and Kohler in 2006, that is promising to make the content easier to understand for users. TPCD has main component as technology, pedagogy, and content. It has three sub-integration components, including pedagogical content, technological content, and technological pedagogy, or TP. As the first sub-component, pedagogical content is using pedagogical principles for organizing the content. For this process, first, we define available knowledge related to a subject or source of the content. Then we determine the goal of website based on what users need to do or know. And then based on that, we draw a goal map. At the next, we decide about materials and for the content for different users. We should know that different users have different background and learning style. When we have the goal map, we need to divide the content to determine topic and subtopics. And then we write outline. Each topic may include text, picture, video, and other visual material. The other component is technological content. Integrating technology and content for designing website refers to the use of different techniques for presenting the content. It is what most website designers are doing. They are usually first select the tool or platform, and then they decide about customizing the template by using add-on or plugin to manage the content, and then decide the content formats based on available tool and techniques. And integration of technology into pedagogy is mostly mentioned for educational purpose. It is usually implemented in two ways, utilizing a learning management system or LMS, or developing a tool for pedagogical purpose, such as YouTube, Google search, PowerPoint, or other tools. If we search top educational tools, we can see that list of these tools that most of them actually are not specified for education purpose. For integration of pedagogy into technology, we use pedagogical theories and principles to design a digital service to help the user to understand the content in a non-educational environment. What we are focusing in our model is actually in that part. Now I explain that how we implement the model in practice. We suggest to design the website through three levels: defining the aim of website, selecting material for the user group, and also delivering material to the website. A successful user-centric website covers the aim of website owners and users. Some user experience methods are used to understand users' needs and expectations. We overlap the user's aim and aim of organization's website to define the objective goal of the website. At the second level, we select the content as the text or visual material based on the aim of website owners and users. The most complex and professional decision in creating a website is determining what kind of material, text, picture, table, graph, or interaction information we are suitable for each kind of content. We actually use pedagogical principles for that. We have users with different age, skills, cultural background, characteristics, needs, and expectations. We should know how to consider these characteristics for constructing the content. We should also consider if there are content, which kind of construct it has. It is linear or non-linear. And then we need to predict the different paths for different users, how they move through the content. In this way, we determine the navigation. The effectiveness of the website depends on providing easy and fast navigation for website pages. All information on the web is divided into pieces that we call it learning content object. Each learning content object includes topic, short text, materials for different users, and also the way that every page is linking to the other page. Selecting visual techniques are based on how the users can understand information easier, faster, or more effectively. Accordingly, some pedagogical criteria are suggested, such as sensibility, classification, or simplicity, meaningfulness, minimality, clear instruction, and also feedback. As a summary, TPCD introduces a practical instruction to apply learning theories and knowledge about users to organize the content and inserting that to web pages in the way that users or end users can find out their information faster and more easy. This figure shows the main component as technology, pedagogy, and content, and also shows that activity in each sub-integration as it was explained in the previous slides. TPCD is promising to offer practical instruction to create effective website. It is utilizing previous attempts such as user-centric design or user-based design and user experience. As implication of TPCD, it can be applied in different technological tools and platforms or template for creating website. We already used it for redesigning a organization website in Finland named Suomen Yrittäjät. As the limitation of this model, we can say that this model is still in the early stage and more application and feedback from the real practice are needed for further development. Thank you for your attention.
Thank you very much
If you
for
have any question.
yeah, thank you very much for the presentation and for the informative research and information for sure. You're lucky you don't have questions on the chat box, but for sure our chair will give some feedback. Also, he will share the questions in his mind. So the mic is yours, Professor, if you have any question or any idea to ask to the presenter.
Excellent presentation. I don't have any questions.
Okay, you are so lucky then.
Thank you.
Okay.
Thank you very much.
Okay.
Thank you for me.
Okay, all the best, dear. And now we want to go to our next presenter. The presenter would be Ms. Intisar Nabilsi instead of Mariam. And the presenter would present an idea under the paper titled as Security Analysis of Smart Home Systems, Applying Attack Graphic. So, Intisar, the floor is yours. Could you please just share your screen, start, and again, we have 10 minutes. I will remind you whenever we're reaching the accepted time frame. Could you please just share your screen and go ahead?
Hello.
Hi, dear.
Can you? I think you need to stop sharing your screen.
Yeah. I will do it from my side. Okay, go ahead, please.
Okay.
Sorry.
Okay. Can you see it?
Yeah, we can see and hear you clearly. Just press it and go.
Perfect. Okay. Good afternoon, everyone. My name is Intisar Nabilsi, and today I'll be presenting about attack graph modeling for smart home system. I come from the German Jordanian University in Jordan, and I'm a mechatronics engineer. The points that I'll be going over today is defining what is a smart home system, attack graph, methodology, results, and conclusion. Okay, so a smart home system, what is a smart home system? A smart home system is a setup where appliances and devices can communicate with each other through an internet connection, and these devices are called IoT of devices. Now, there's a difference between things on internet, TOI devices, which only provide connectivity, while IoT devices, Internet of Things devices, they talk directly with each other, make decisions and exchange data without the need for a cloud or a server. Now, I chose KNX because although there are several bus technologies on the market like Zigbee, Z-Wave, but there is no other bus technology that is supported by as many different manufacturers as KNX. And this is because they can accommodate a huge range of functions and their products are compatible with other products from other manufacturers. So they're interconnecting. Okay, now, what is the difference between BAS system building automation system, or in other words, building management system, and a smart home system. Now, building automation is a system that allows for automatic and centralized control of a building's energy system, such as heating, air conditioning, and lighting. They allow for the building's manager to control the system remotely through a handheld device. While also, building automation, it uses a computer networking system to monitor and to control the building's various systems. These automated systems use information such as the building occupancy, work schedules, temperature preferences to monitor and control the various operational systems within the building. While a smart home system, you use a smart device like your phone, an iPad, to control the entire to control the entire house, and it can be a building, but a building is composed of several smart home systems, not one entire one. Now, I chose to do about smart home system instead of the BAS system because they are less expensive than BAS system, and they consume less energy. So I think it is the future. So that's why I conducted my research on a smart home system. Also, smart home systems, they use IoT devices, unlike BAS system. And we can say that smart home system is an expansion of BAS system. Okay, now this is the structure, or the structure of a KNX system. The topology. As you can see here, this is an area. Okay, this is an area. It is for example, a room is composed of multiple areas, and this is the KNX IP router that allows each area to communicate with the other, and the devices to communicate with each other. So this is my target. This is the target. If I get to here, I can get into the system. Okay. These are the devices that I connect, for example, a camera, a light, shutters, whatever I want. Now, I'll be talking about incidents that happen on smart home systems. With the fast change technology nowadays, systems are becoming more prone to cyber attacks, and as these attacks have many consequences, they can shut down systems, they can leak sensitive information. So to prevent these consequences, organizations, they need to prevent the system flaws that are vulnerable to attack. Now, attack modeling is one of the methods that is used to address these flaws. Okay. Now, the incidents that happened. This is a table that summarizes the incidents that happened. So, in October 2016, the DYN company, a DNS, low domain name system, was attacked by a Maria botnet, shutting down the entire system. The DYN company has Twitter, Instagram, and so on. February 2017, Spiral Toys, smart toys, they were attacked, and they had the children's voice recording played inside the toys. And in 2019, if you heard about it, it went viral. A homeowner was attacked, and a guy was able to talk through the camera with a child. The camera was inside her room, and he was able to talk to her. Now, the attacker's goal and threat scenarios. So we are trying to get unauthorized access on the system and to control the devices. Okay, I explained briefly what is an attack graph modeling that I'll be using prior to that. So it's basically, attack modeling provides organization with a systematic analysis of the potential attacker's profile and the most likely attacker vectors and the assets most desired by the attacker. Okay, now, so attack modeling is a process of security risk analysis. It identifies and prioritizes potential attacks such as structure, vulnerabilities, or from a hypothetical attacker's point of view. So we just suspect where does the attacker want to reach. Okay, now And the methodology, so it consists of 5 points: identifying the system topology, identifying the threats and the vulnerabilities of the system, formal description, the system, AADL simulation, which is the language we'll be using in this research paper, and then visualization. Okay, so this is my system. Okay, so it is considered of an access point level. This is the first level, AP. The attacker is assumed to be located at this point. Then we have the management level, which is the device that gives the order. The device that gives the order is found in this level, such as a laptop, an iPad, or a cell phone, any smart device that you want to use. We will be assuming a cell phone is located at the management level only. This is the KNX IP router. It consists of KNX devices that communicate. So the KNX IP router helps other devices communicate with each other through the KNX router. So it's basically similar to a Wi-Fi router, but it is specialized for the bus system. Okay, this is the field device system, denoted as F. It is the KNX bus, where all KNX devices are located, such as shutters, fan, light, and air conditioner, and the IP cameras. Okay, so we have 3 network backbones: Wi-Fi network 1, Wi-Fi network 2, and Wi-Fi network 3. So the access point is connected, or it communicates with the management level through a Wi-Fi network, and so on. Okay, now the vulnerabilities of the system. Vulnerabilities are holes in the system. We have 2 vulnerabilities in our research paper, or in our system. Commercial off-the-shelf vulnerability, or COTS, which are products that are designed to be easily installed and to interoperate with an existing system. They all use the same software to help organization install systems easily together. And as a result, this causes holes. It's also COTS are found in cell phones. Now, lack of authentication, or LAO, denoted as LOA, is when an attacker claims to have a given identity. The software does not prove or insufficiently proves that the claim is correct. The attacker will access the KNX IP router and pretend to be someone they are not. Okay. Now, possible attacks on the system are denial of service, DOS, routing table poisoning, RTP, persistent attack, man in the middle, phishing attack, malware injection, and social engineering. Okay, now denial of service is an attack used to shut down a machine or a network, making it inaccessible to its intended user. This is done by flooding the target with traffic, giving knowledge over the target. This attack exploits the COTS vulnerabilities on the management level. Okay, I just want to explain something prior to these. Okay, yes. So the system formal description, it consists of static variables and dynamic variables. The system connectivity is denoted as Q. This is how the system is connected to each other. We have system vulnerability, V, LOA, and COTS, which we have explained prior to that. And then we have the dynamic variables, the attacker level privilege P, and the data knowledge. I'll go back to explaining the attacks very fast.
Yeah, sorry, but you have 4 minutes. Just please try to make most of them in the rest of the presentation, not to wait your efforts.
Okay, so routing table positioning is done by attacking the routing table, which allows exchange in a router by a malicious change in the routing table. Persistent attack, this attack injects continuous harmful data on the Wi-Fi network, and it uses LAO vulnerability. Man in the middle, it occurs when the attacker accesses a link, like Wi-Fi access point, between 2 parties. Phishing attack is when the recipient is tricked to open a malicious code revealing sensitive information like login credentials. Malware injection, this injects malicious application into the operating software of the host so we can edit, copy sensitive information. Social engineering, this attack generally targets enterprises and organizations where an attacker uses a human to get critical information or in order to get the system. So this is the system formal description of the system. Now, the initial state that I start from is from the access point. I have no privilege and no knowledge, and this is the security property where I want to reach. So I have privilege, no privilege on F, which is field level devices, and I want to reach that I have root access on it. This is the system AATL that I used. Is the language that we coded everything with. This is the code in details. This is the result. This is the counterexample. This is a counterexample. So every time you see true, it means that this attack is true. So first of all, here is SE, and then P, and then phishing, and then persistent attack, and so on. This is my attack graph, how the attacks are being conducted step by step. And attack graph describes okay, 1 minute. Okay, so a graph attack, it summarizes all the cyber scenarios in a graphical representation of an attack graph. It's an open supply source that we use in order to conduct it. From the graph here, you can conduct that, and we conducted that intrusion detection system. IPS can be used between the management level and the KNX IP router, and IPS will inspect the content of the request and be able to drop alert and potentially clean a malicious network request based on that content. A firewall can also be used to protect the system.
Yeah, and so you have 1 minute, so could you just jump to the conclusion?
Okay, so as a conclusion, we found that our buildings are becoming more and more smart, and cybersecurity should be important and should be a concern for the customer. Thank you for listening. If you have any questions, please ask.
So thank you, dear Intisar, for the presentation, the great efforts. It's very clear that you have paid, IU supervisor paid the great efforts in the idea and in developing the presentation. So thanks for that. You are lucky as well. You don't have questions in the chat box. However, let's see if our chair has any question, comment, input to your idea. So, Professor, do you have any question or anything to contribute to the research of Intisar? Excuse me, Professor, do you have anything? Okay, just a second, let's check. We may miss the connection with the professor. Okay. Then, Intisar, we will get back to your presentation to see if there is any question when we have another connection with the chair, and we will move to our next presenter. Just a second. Okay. So after that, we will move to our next presenter, Faisal. Mr. Faisal, I hope you are with us and you are ready to share your
Yes,
experience. Start. Mr. Faisal will will present on behalf of the co-authors a paper titled as a rule-based Bengali grammar checker. So it would be interesting and very helpful to most of us. Please go ahead with the presentation, and we are all listening to you. All the best.
thank you.
Yeah.
Can I see my screen?
Yeah, dear, we can see it clearly.
Okay,
Go ahead.
thank you. Hello, everyone. My name is A.N.M. Fahim Faisal, and my fellow authors are M.D. Afikur Rahman and Tanzila Farah. We are from North South University, Dhaka, Bangladesh. I'm now going to present our paper, which is titled A Rule-Based Bengali Grammar Checker. The presentation is divided into these sections. In the introduction part, I'm going to give a brief overview of the fundamental research. Then I will describe our motivation behind the work. In the next section, I will state the problem. Then we will look into the solutions available for the issue and our proposed solution. After that, I will discuss the method we followed. Finally, there will be a result analysis and then a conclusion. Well, natural language processing or computational linguistics is a subfield of artificial intelligence that is growing very fast. But unfortunately, there has not been much work done in terms of the Bengali language in this sector. So there has been works done on spell checking, text to speech, and optical character recognition for Bengali. Since there has not been any significant work on Bengali grammar checking, here we have built a system for checking the grammar of Bengali text. To check the grammar of Bengali sentences, we have written a few grammar rules considering the fundamental dependencies of different parts of speech on each other. So Bengali is now widely used in different sectors, both nationally and internationally. We Bangladeshi people here in Bangladesh use Bengali in offices for business purpose, for educational purpose, in media and in literature on a regular basis. According to the Internet World Stats, almost 100 million Bangladeshi people are using the internet at this moment. You can see in figure 1 that is almost 60% of the total population. 45 million of these internet using people are on different social media who use Bengali for writing every day. As I said in the introduction, no grammar checker, sentence structure matcher, or proofreader can serve this vast portion of the users for both formal and creative Bengali in their day-to-day life is available at this moment, which creates a growing need for such a tool. There are not many notable works done or tools made for detecting errors in Bengali text. We found the only existing work in this field is the n-gram-based statistical grammar checker for Bangla and English, which was done back in 2006. We have gone through a few other grammar checkers as well. Among them, the Afan Oromo grammar checker and the Punjabi grammar checker helped us a lot in this research. We chose rule-based approach for this research because it's a better option. Here in the rule-based approach, we're writing the grammar rules in the system manually. So it gives us the better output. Our solution is divided into two segments. The first segment is called tokenize and tagging, and the second segment is grammar rule matching and parsing. The first segment takes a sentence and tokenizes it to separate words, detects the correct parts of speech of those words and tags them with post tags accordingly. Then the second segment receives the appropriately post tagged sentence, which is parts of speech tagged sentence. It matches the tagged sentence sequence with our manually written grammar rules and detects errors, then marks the wrong words. Here in figure 2, we can see the whole process with the two previously mentioned segments. Each segment performs two different tasks. If we look uh, at the figure 2, here you can see that in the first segment, here we have tokenizer and post tagger, two separate tools to do different work. And then the post tagged sentence goes to the second segment. And here we run, basically the system runs the handwritten rules on the sentences and sends it to the parser. Finally, we get the output from the parser. Generally, a Bengali sentence consists of two different parts, subject and object. In Bengali, we call them uddesho and bidheo. Therefore, the simplest Bengali sentence structure can be written as subject, then object, and then verb. Whereas in English, it is subject, then comes the verb, and finally there's object. In table 1, we have listed all the post tags we used. The post tagger we use here had some redundant post tags which were incompatible with our system. So we changed the output from the post tagger to match our system's requirements and ended up using these 7 tags, which are N, which we used for noun, then PN for pronoun, DET or date for determiner, JJ for adjective, CCP for conjunction, ADV for adverb, and V for verb. We divided each sentences into different phrases. For example, we have used adjective phrases, noun phrases, and verb phrases. Then we wrote regex patterns, which is widely known as regular expression, and we wrote the structure rules for Bengali sentences in regular expression. If we look at the table 2 here, we can see a few of the rules written and integrated with the system. So let's take a sentence for example. The sentence here is she ebong ami bideshe thaki, which translate to English as he and I stay abroad. Our system first takes the sentence and tokenizes it and tags it appropriately, that we can see in the section 2. Then it goes through the handwritten rules and gets parsed. For this particular example, the sentence is actually structurally correct. The system detects the correctness of the sentence by looking at the parsed tree. If we look at the parsed tree, that there we can see that every single word in the sentence got parsed. That means got tagged. That's how the system can tell once if a sentence is correct or not. Let's take another example where the sentence is basically incorrect. The sentence is বৈজ্ঞানিক একটি এটা বিষয়, which translates to English as this is a scientific matter. Basically, we are here saying, telling you the correct form in English. So when this sentence goes through the system, it gets tagged and then goes through the parser, and finally we can see that in the tree that বৈজ্ঞানিক, which is tagged JJ, the word বৈজ্ঞানিক, which is word JJ or adjective, and the word ekti, which is tagged date or determiner, didn't get through the parser or got unparsed. So this means that these two words are not in their appropriate place according to the rules. That's how the system can tell that if a sentence is structurally wrong. So here we can see in figure 5 and 6 a difference between structurally correct and wrong sentence. Here the sentence is তার কিছুই মনে পড়ছে না, which translates to English as he cannot remember a thing. So if we look at these trees, we can see in the incorrect sentences the word kichui, which is tagged det, didn't get parsed. So this sentence is not structurally correct. We have built a prototype web application for the system where the user can input sentences and check if the sentence is structurally correct or not. Figure 7 shows a snapshot of the web application with the sentence checked to show a parse tree indicating a misplaced word in the input sentence. For result analysis, we took 2 sets of sentences to test the grammar checking system. 50 are correct sentences and the other 50 are incorrect. The incorrect sentences are made by rearranging the order of the correct sentences to make them wrong in structure. After testing both sets, we found an average of 86% accuracy, almost 9 sentences on average out of 10. Our work addresses the issue of not having such a tool to check and find out errors in Bengali sentences. Structure and implement one platform that checks Bengali sentence formation by using rules. To summarize, this work's contribution includes classifying words into 7 parts of speech tags and run individual restrictions on them, or restrictions or rules on them for checking nouns, adjective, and verb phrases. We hope to build an improved post tagger for the system in future, which will make the system much more efficient, and a suggestion system could be created using statistical method also. So with that being said, I'm concluding my presentation. Thank you everyone.
So thank you for the presentation and for the great idea. You don't have the questions on the chat box. However, I will ask you about how much that it's dynamic, the idea that you are trying to implement. Okay, you have mentioned your language, you have mentioned the English as well. So if I want, for example, to add the French, would it be dynamic to include the other languages, or is there a way, for example, to connect it to any database to import? Any
No,
part of any database, or this is not applicable?
no, not actually. We're not using any database here.
Okay,
We have written the rules based on the grammar,
okay,
specifically the Bengali grammar.
the Bengali
So
grammar.
yeah,
Okay, okay, and this includes everything related to the Bengali grammar. I
yeah,
mean, in case it's already fully written by you.
yeah.
So it's a great idea. Thank you for that. We are all use similar application, and it's very helpful. So thank you for the contribution.
Thank you so much.
Now, yeah, now I want to get back to our chair if he has any question
Thank
or
you for
any
the
note.
very interesting presentation. I don't have any questions. Over to you,
Okay.
Farouz.
Okay, okay, thank you. Thank you. Then we will proceed to our next presenter. Now we have Jeffrey Islam from North South University, Bangladesh. She will present on behalf of the co-author a paper titled as Multi-Purpose Automated Car. Another interesting idea and topic. The floor is yours, Jeffrey. Could you please just share your screen? I will stop it from my side. Share your screen and go ahead with the presentation. We are all listening. Thank you.
Okay.
Yeah. There is a green button in the bottom of the screen. Yeah, it's working now.
Greetings of the day to all the dignitaries present today. I am Zafrin Islam from North South University, Dhaka, Bangladesh, and I am presenting behalf of my fellow author Redwan Islam Rahat and respected Dr. Muhammad Rashadur Rahman. Today I will be presenting our project, which is multipurpose automated car. So, the motivation of our project. Automated vehicles are transforming the way we think of mobility as technology advances. Self-driving technology is now the most widely discussed technology in the automobile industry. But according to the World Health Organization, over 1.3 million people die on the road as a result of traffic accidents. Non-fatal injuries affect an additional 20 to 50 million individuals, with many of them resulting in disability. And self-driving car accidents occur at a rate of 9.1 per million miles driven compared to 4.1 per million miles for normal cars. So you can see that self-driving cars have a greater accident rate than human-driven cars. That's why for assuring more safety, we add different features with our automated car, which will increase automobile safety and performance and also better control system in our practical life. Introduction. With the development of technology, everyone prefers multipurpose devices. Many automotive manufacturers are now developing self-driving cars, but there is still the possibility of failure. The presence of other drivers, cyclists, and sudden barriers are all issues that autonomous vehicles face. That's why for minimizing these issues, we add different features with our automated car, like line following, object detecting, object avoiding, and also manually control system. At any speed, an automated car should be stable on the lane. Higher speeds should be realistic because they will be powered by algorithms, which will minimize human error as a source of accident. Now this project has handful of fractures which can be used in many different ways, from the big bus to the small neighbor-friendly car, which help keep distance. We tried to maintain our project as low as reasonably achievable. Here are some key requirements for our car. For hardware, we used plywood, chassis, Arduino Mega, color sensor, servo motor, ultrasonic sensor, and Bluetooth module. Software requirements for our car is Arduino IDE to write code and upload it to the board, processing tool for manual control system, and FreeSync for circuit design. To increase automobile safety, we add different features with our automated car, which is line following, object avoiding, object detecting, and also manually control. This is a combination of self-control and manual control system. It can collect data from the sensors and decide next instruction based on the sensor data. A multipurpose automated car is structured using Arduino Mega. The proposed automated car performs a wide range of functions with the help of the sensor. It identifies and avoids obstacles using an ultrasonic sensor and a servo motor, and using color sensor it can follow the line. A Bluetooth module is also added to build wireless communication so that the car may be controlled using a smartphone or laptop. Therefore, our first feature of multipurpose automated car is line following. A system that can follow a path and detects is known as a line follower. This is a system that is normally built to minimize the amount of human labor required in the areas where it is used. First, we selected a design for developing a line follower with color sensors and an Arduino Mega connected via a motor driver IC. A line following car's efficiency is influenced by the line width and color. This line follower car is set up to adopt any color line on a surface as long as it is not the same color as white. It is following a white line and track this line. Color sensors are located in the front of the car's two ports, one on the right side and the other on the left. For the line, we used a white electrical tap. The car detects the white line using color sensors. If we convert the sensor's analog readings into digital values, then sensor readings for white surface is 1, sensor readings for black surfaces is 0. Here in this table, we can see conditions for movement in the line following car. Then our next feature is object detecting and then avoiding the object for automated car. Obstacle avoidance is an important part of local route design and one of the most important technologies for ensuring human and car protection. First, we selected a design for developing an obstacle avoiding automated car and an Arduino Mega connected via a motor driver IC, and the car detects the object. Ultrasonic sensors are used to direct the obstacle avoidance car. The ultrasonic sensor is attached on the car's front edge. The ultrasonic sensor transmits ultrasonic waves continuously from its sensor head while the car is traveling along the desired direction. When it detects an obstacle, ultrasonic waves are transmitted back from the object and this information is transmitted to the Arduino Mega. The aim of this feature is to build an automated car that can identify obstacles in its path and operate based on the acts we assign to it. This automated car has intellect built in, allowing it to navigate itself around obstacles, as a result to secure the car from physical damage and collisions. Then another feature is manual control. It is a control system where a system controlled by the physical strength or simpler working principle. A lot of the time manual control is used for emergency. It is absolutely imperative to have a manual system for multipurpose automated car. We will send the instruction from a computer which will transmit a processed instruction to the car through Bluetooth. We have an automated car that we would like to control remotely using a keyboard and Bluetooth. We will need a computer or laptop or a smartphone as well as processing tools to accomplish this. The control system has some instructions that need to be followed to operate the car. Control system operate in key pressed function. Here is some instruction: M for manual mode, W for forward, D for right, A for left, T for test the sensor, L for activate line following function, O for activate object avoiding function, and X for stop. This is the hardware prototype of our multipurpose automated car. The automated car's frame is made of plywood so it can bear more weight and it is also lighter in weight. In near future, autonomous vehicles are supposed to be common on our streets. When our self-driving cars become a possibility, our world will face certain economic impacts. This is a model of a multipurpose automated car manufacturing and assembly system that has been created. The car would not be able to detect and follow the path if the width is less than the minimum line width necessary, or if the line color is not properly calibrated. 5 modes in our automated car: forward, stop, move backward, search right and left, and turn right or left. Since there is only one distance sensor in this project, the sensor must be able to turn around and look for possible ways to go. So it must be attached to a servo. The servo shaft can be rotated 180 degrees to assist the sensor in scanning the environment for obstacles and selecting a direct direction to travel through. If distance is greater and equal than 20 centimeter, then our car will be stopped there. The device should be fault tolerant, which means it should be able to keep running itself even though anything goes wrong. Testing mode is to check the sensors if they are working properly or not. In testing mode, it works perfectly. The software's picture of the manual control system is presented in the figure, which is controlled by the user commands. Limitation. First of all, the prototype was supposed to be the same size as the finished product, but it shows clearly that a chassis of this size would be costly and difficult to obtain by. We can use LIDAR sensor for better object detection. We faced some problems due to power supply management. For that, our car battery drained too fast. This has happened due to the low cost gear of the motor. We tried to maintain our project as low as reasonably achievable. In the near future, we want to apply the automatic parking feature, add GPS and IoT-based control system, and add a camera to improve the accuracy of path recognition and tracking for the development of our car. Conclusion. Robotics has an edge over many other similar innovations because of its high efficiency, high precision, low labor cost, and capacity to operate in dangerous environments. This paper is focused to increase automobile safety and performance, freeing up people's time, more perfectly object detection, and prevent traffic collisions in our practical life. So, by combining those all features, our automated car can be operated in a sustainable and efficient way. Therefore, now our automated car is safer, reachable for peoples, and our car has an advantage over many other innovations in terms of efficiency. This concludes the presentation, and on behalf of our team, I thank you all joining us for here, and I would be happy to answer any questions or queries you may have. Thank you so much.
So thank you, dear, for the great presentation.
Thank you,
Is there a
Jeffrey.
question?
Yeah, I have a question.
Yeah, please.
So, Jeffrey, you have used this prototype for a normal kind of prototype, but not an actual car, right? A normal prototype has been created in lab, and you have used all the techniques, all the things to on that prototype, right? But when you do it practically over the actual car, do you think that there would be challenges because the battery consumption and the sensor detection for a small object and for a much bigger object and all that things? Do you think there will be a loophole in that?
Yes, I already mentioned in my limitation that a finished product and chassis would be difficult to obtain by. So it would be something difficult.
So have you done some analysis over that what will be the future if this is done over an actual car, and how your product or how your efforts would be recognized there?
We made a demo to we try to do it in our real project. That's hello.
I am not able to hear you. Can you speak slightly loud?
Hello. Hello.
Yes, Jeffrey,
I think
could you please just
thank you.
raise your voice? Yeah.
No
Can you?
worries. I think it's done for me, and I think Professor
Okay.
Vijay is already here. So what do you, Professor? If you have any questions.
Yes, I do. Actually, this car, obviously, it's I shouldn't say a toy car, but essentially, you're using a white line to, for the car to track around. So obviously, you're using a light sensor there to track the direction in which the car is going to move. Is that correct?
Yes, yes. I used a white line for.
Okay. In obviously a real scenario, that will not be the case because you'll be driving on a road. So have you thought about what kind of sensors you'll need so that your car can maneuver and avoid people and objects and obstacles like that?
Here I used another sensor for obstacle avoiding. So I don't think if I um, miss this line, if I can't use this line in road, but I can also use object avoiding and obstacle avoiding. I can, because here I use ultrasonic sensor and servo motor so that I can do this.
What I find is that acoustic sensors, they penetrate clothes and they don't really reflect very well. So obviously you need to use different sensors when you're developing your system for real world application.
Yes, we have some limitation with our. We try to this project is achievable for everyone. That's why we use that sensor is achievable for anyone, affordable. We use that sensor. That's why
Okay,
we
I don't
will
have any
work
more
on this.
questions.
Thank you so
Sure.
much for your
Thank you.
valuable suggestion.
Thank
We'll
you.
incorporate it on future work.
Yeah, thank you for the presentation, the questions, and the improvement suggestions. And now we want to move forward to the next presentation titled as Development of Virtual Reality Training System Based on EEG Biofeedback, presented by the author Ms. Lin from Hankangu University in Taiwan on behalf of the co-authors. So, Ms. Lin, the floor is yours. Could you please just share your screen, turn on your mic, and go ahead with the presentation? Thank you. Yeah, please, could you start? You're muted. Sorry, we can't hear you. You may be muted. Could you please just double check your mic, the settings, or we have lost. Okay. Then, if possible, meanwhile, while you are trying to fix the mic issue, we will move forward to the next presentation. Or are you ready?
Sorry, can you hear me, my voice?
Yeah, I can hear you. Sorry.
Okay, sorry.
Yeah, it's fine. Okay. Could you please just share your screen and go ahead?
Okay.
Yeah, we are all listening.
Sorry, I can
Okay,
my...
there is a green button lighting on the bottom of the screen titled as share screen with an arrow in the middle of a rectangle. Just press it and select your active screen.
I can find our PowerPoint in file screen.
Okay.
Sorry, maybe waiting for me a minute.
Okay. If you wish, I can push you a message, send it direct to me, or using the chat, and we will flip the presentation with the next presenter and get back to you to get you ready and comfortable.
Yeah.
Okay. So, would you mind
So maybe
just?
I leave and join again.
Okay. If you don't mind, we will just switch the presentation to the next presenter and we will get back to you. Please send me the presentation by chat and I will share it from my side. No worries. Okay, sorry for the misconvince, but it's the consequences of COVID. And now we want to be dynamic and go to the next author. I'm really sorry if you are not ready, but again, we are dynamic enough in the circumstances even to present without any further notice. Miss Jessica, who would present on behalf of the co-authors a paper titled as Enabling a Question Answering System for COVID using a hybrid approach based on Wikipedia and QA pairs. So I'm really sorry, Madam. Are you ready to present? Miss Jessica? Or Miss Lynn? Anyone of you is ready to present? To share the screen and go ahead?
Okay, yes, I
Yeah.
can.
Yeah, if you can, yeah, we can start with you. Just share your screen and go ahead. Thank you for that. Okay.
Sorry.
Yeah, it's fine. Just
Okay, can see my screen and my
yeah,
voice?
it's brilliant.
Okay,
It's brilliant. Go ahead,
I
sorry.
start my presentation. Okay. Thank everyone for attending this conference session. And today I'm here to present the paper, Development of a Virtual Reality Training System based on EEG by feedback. So this is my outline of this about this presentation. Firstly, I will give some introduction about this work and show some related work. And now I will show our development system about the system principle and the technology. And finally, I will give a conclusion about this presentation. And for the introduction, as we know, VR is widely used in the medical field, and it can transfer the severe pain in penalty, and also can rewrite the relationship between the penalty's brain and the muscle nervous system, and also use the feedback training to improve the physical or cognitive performance. So if we integrate the EEG feedback technology with the VR training technology, it also can provide feedback when the patient complete the text action. It can help to the patient to improve the training efficiency. And this integration also can help the stroke patient adapt their actual situation through the motion simulation. This simulation also can improve the efficiency of the rehabilitation. Okay, so in this study, we cooperate with physical therapy expert to develop a remote rehabilitation system. And this system, we collect the accuracy of the patient movement and the duration when they perform the rehabilitation process, and upload this data to our cloud and in our system. This information can for the patient and or the therapy or doctor to make some judgment to the rehabilitation progress. Okay, so our system also support multi-user connection. We use the PUN to construct a multi-user rehabilitation platform, and also use the 3D to provide the connection function and environment to create a VR equipment tracking for when we perform the rehabilitation process. So patient can connect remotely with our system and communicate with their therapy to perform the layer rehabilitation process. So our system also allow the therapy to guide their patients action and increasing our VR interactivity. Okay, so in recent years, maybe some research also development a rehabilitation game system, RGS. And for example, for the research team for the Neurosclerosis State University and the University of Chicago, they create an online VR exercise system. This system is called the VRGE. And they are allowing the patient to interact with other patient and the therapy on the internet at home and for perform some rehabilitation process. So also in our research, we also see other research have also confirmed that the VR combined with the multi-user can encourage the patient to receive a treatment and achieve a good result. So it may be a social relationship. So improve the patient's ability. Okay, so in addition, the EEG is also widely used in the medical community. They can digital certain neurological growth. So in EEG, we can use the recorder electronic field. They can generate by the neural cell activity. They can use to investigate the recovery mechanism of the treatment after the actual strong phase. So in this EEG, if we integrate it with the brainwave technology, we can use it to monitor the change in the activity of the patient's left or right spine, the brain wave signal for the patient when they perform the rehabilitation phase. We can collect this information to show some this information for the therapy to make a judgment. Okay, and if we consider a dynamic analysis, we can integrate this brain EEG feedback signal to display or monitor information in our VR test screen in real time. It also can in real time show layer therapy or itself to see the status of the brainwave. Okay, so now I will introduce show our basically system principle and technology we use. So the system we develop the system we can support a single and multiple condition rehabilitation mode, and also can provide the rehabilitation guide and explanation during the training. So patient can perform a remote multi-user connection with our system and communicate with layer therapy. And by this system, we can follow their posture and movement when they perform the rehabilitation to improve the accuracy. So this slide is show the overall of the functional of our rehabilitation system. We can see we support a multi-user and a single user. For the multi-user, we development reaction training, memory training, balance training. And for the single user, we development occupation therapy, main role therapy, or concentration-induced movement therapy. So by this system, you can use the patient can use this system to perform these 6 different therapeutic training. Okay, and this slide we show we use the emotive inside this equipment to collect the EEG feedback to show our and do some transformation and show our system. So this slide left in this figure, the left side is the emotion inside indoor placement. We can see he have the 5 electronic placement, and the left side is the international electronic placement. So we basically use this equipment in our system and to get the brainwave signal and apply our system. Okay, and later I will show our how to use this signal to show our training, our rehabilitation system in our VR screen in real time. Okay, this slide is show our VR rehabilitation integrated with the BCI design. We can see this is the example for our training system, rehabilitation system. We can see in this screen with the Kevin Aperture, he embedded in the upper left side of the screen, and this slide will show our EEG signal. So if your EEG signal in the patient's brain, we can see in real time. He will show maybe the patient's motion or signal. Maybe some part have the high signal and the other part maybe have a low signal. He can reflect this signal, and we use this signal to can make some recommendation or adjust the personal rehabilitation treatment. So we can see how to use the transformation, the brainwave signal to the emotion, because maybe when the patient perform a rehabilitation system, the therapy can see this emotion status to see how the motion status of the patient and adjust the rehabilitation process for the patient. So in this book, in this slide, this is the variance and ultra coordinate. So this slide we will transfer our brain wave signal. We get the F3 and the F4 placement, electronic placement. This is in the photo level signal. and it have a high range over beta H or beta L, beta wave. Right? We can divide by the electronic code, and the value will show this value in this VR screen. And how to transfer the EEG signal to the extra or variance? We use these two equation, first equation and the second equation. And in this equation, the F4 and the F3 signal is get from our EEG handset. And we also use some API to output these two value and use this equation to calculate the extra and the variance and show in the list extra and the variance coordinate. Okay, so the therapy can see the emotion of the patient in this screen in real time. Okay, so and then I will we in our system we also use have the integrated or development of music element to assess brainwave activity. So this music environment, we also consider the three parties, the brainwave parameter extraction. It can extract the brainwave data, and according to this data, input the second, store into the database, and input our personal brainwave assistant measurement system. So we can use this the patient's wave brainwave to give a customized music list. And you also can, when the patient perform the rehabilitation process, we can also get the brainwave in real time and according their motion to give another suitable music list, and maybe you can improve the rehabilitation process. Okay. So for this music element, we have the two, as I mentioned, we have the two mentioned components for the brainwave parameter extraction. We also can get the brainwave signal and transfer to the system, and its temperature a default music list. And when the patient perform the rehabilitation, you also use this real-time data to adjust this music list to recommendation, maybe some suitable music in current status, in current situation for the patient. Okay. So for the recommendation, we also have the personal brainwave assistant measurement system. We have some transformation module and the detection module, and also this also including the reasoning module to recommend the music list. Okay. So finally, I maybe give a conclusion about this presentation. So in this study, we use the VR and integrate EEG feedback to implement a rehabilitation therapy for the patient. So in this system, as doctor maybe lead to the physical impatient of the patient and affect their behavior or cognitive ability. And also we in this system also can guide the patient to apply the rehabilitation movement or the occupied therapy. It can assist them with layer training. So especially in this consideration, worldwide under severe condition of COVID-19 situation, maybe the patient want to perform a rehabilitation process, but you don't want to go to the hospital, and maybe the hospital has face a capacity problem. So our system can help the patient and the layer therapy communicate with our system, and the therapy can monitor the patient's rehabilitation process and their motion, and give a suitable guide to adjust the rehabilitation process. Okay, so the system also, we also can provide the multi-user environment. So he can communicated by our system, have a great conversation. Okay, so in the future work, we also want to improve our accuracy and to detect the patient's movement maybe the triangle of the limb or skeletal. So in order to achieve this goal, we may be in progress to integrate the mixed reality (MR) technology to improve our timeless of the critical evaluation of the physical therapy. Okay, so this is my acknowledgement for the help our to finish our work. Okay, same for the organization and some help our people. So finally, I finish my presentation. Thank you, everybody. Have any question?
Thank you for the great presentation, great idea, and huge efforts in the presentation and in developing the research project. So you're lucky you don't have questions on the chat, but let's see if our chair has any contribution, question, feedback, or recommendation to extend the idea. So, Professor, do you have any question?
Very, very interesting work. It would be interesting to see the results when you have tried your system on real patients. I think that's another paper that you need to present. So very good work. Thank you so much.
Okay.
Thank you.
Thank you. All the best, dear. And now we have our last presentation for this session with Miss Jessica. She will present on behalf of the co-authors a paper titled as Enabling a Question Answering System during COVID using a hybrid approach based on Wikipedia and QA pairs. So the mic is yours and we are all listening to you. Thank you for your time and effort in advance. I will stop the sharing and go ahead, please.
Good afternoon. Thank you for the presentation. Let me share my screen.
Yeah.
Sorry.
It's fine. Yeah, we can see it. Go ahead, please.
Right. Thank you. In this opportunity, I will present the research enable a question answering system for COVID using a hybrid approach based on Wikipedia and QR pairs. In this work, I made the proposal joining with Najet Boujet Aja from Universitat Oberta de Catalunya. I am from Ecuador. I am working in the Universidad Técnica Particular de Loja. The schedule or the agenda for this occasion is motivation. Then I will present the approach. In third pass, I present the experimentation, and finally I conclude this work. In this, to start the presentation, I will introduce the main motivation to do this proposal. The proposal is used of can be used to the COVID domain, but this architecture can be used in other domains. The main motivation is COVID because there are a lot of information about the topic, but there are a lot of fake news or fake information which produce misunderstandings or the diffusion of bad information. In this context, the research on COVID-19 disease has produced much information, but there are more questions than certitudes. Scientists and authorities have many questions, but the general public is also concerned and has many questions about this topic. Keeping people well informed is crucial to ensure collectively responsibility to maintain the virus spreading under control and take care of each other. Making a review of literature, we found that there are a research gap because There are a lot of many works about QI applications, question answering applications for the domain of COVID-19. In this table, we view some several approach in which authors have developed some proposals, but we found that many of these works are focused on the scientific users, not are available for public, general public or the community, because these proposals are focused on a specialized data source named CORD-19. CORD-19 contains the metadata for several scholarly production. This is not suitable for general public. Our proposal has this architecture. In this architecture, we create three kinds of data source. We extract information from three data sources as the figure shows. First, we collect page of fax pairs. We collect information from Wikidata, Wikipedia, and finally, we collect information from a Wikipedia page. To collect information of the three sources, we construct or we create several different repositories. First, the QA pairs collected from fax page were stored in a data store. The information extracted from Wikipedia and Wikidata were used to create a controlled vocabulary. And finally, the information collected from Wikipedia was used to create a document store. Then when we finish the collect information, we design the QA components. These components are composed by a query processor, a retrieval and query engines, and finally the answer processor. Three components are used to find similar questions in the QR pairs data store, and the retrieval and query engine is responsible to find the answer in the document store based on Wikipedia page to choose the best answer, to choose the best answer to the query user query. Finally, the answer processor is responsible to prepare or to enrich the answer to the user. The three main sources used to collect the question answer pairs were the site of facts from CDC, WHO, and CNN. In this table, we can show the main topics or the main subjects are related to the questions. From the Wikipedia, we traverse the knowledge graph starting from COVID-19 category, SCOS category. From this main concept, we collect about 1,600 pages, and then we fragment, we divide this page in more than 8,000 sections. With the information of Wikipedia and Wikidata, we construct a controlled vocabulary for COVID domain. At the right, we can show a part of this controlled vocabulary. In the root node, we show several concepts related to the COVID domain. We construct this vocabulary because the existing API were not available to identify some terms related to COVID domain. This is one of the contributions of this work. When we implemented some components of this architecture. When we finished the implementation, we carry out some steps related to experimentation. We evaluate the query processor, which is responsible to find or choose the best answers of the system similar to the user question. In this example, the test question is, can hand sanitizer protect against COVID-19? And the system select the best answer, question, related to this user question is hand sanitizer is recommended. And the system choose other proposals, other response found in the system. We evaluate this component manually, in a manually way. We found a precision about of 81, more or less. It is a precision of this system. And then we made a qualitative evaluation. In this example, we can see the answers, probably answers for a question related to can hand sanitizer protect against COVID-19? The system found these answers. In this output, we can see our automatic score found by the system. But important thing in this output is the text received by the user is not a plain text. It is enriched output because we can see some semantic annotations. For example, antibacterial, antiviral, where URIs represent identifiers of semantic resource available on Wikipedia.
Okay, sorry for interruption, dear.
User,
Yeah, you have 1 minute more. Sorry for interruption. So could you please just jump to the conclusion?
Yes, yes. To finish this explanation, we can see some metadata related to the output. And finally, these are the conclusions. To cover the continuous demand for information that the community has about COVID, some initiatives have emerged focused on creative information systems, such as search engines and QA systems. However, the majority of those proposals are based on specialist text corpora in the biomedical domain. Therefore, they are intended to provide answers that only domain experts would understand. In this paper, we present the architecture of a question answer system that was designed to be used by the community or the general public. In addition, we implement the main modules of the system in order to carry out a proof of concept. During the experimentation, we detected that there are questions for which the system did not find results. Therefore, to improve the system coverage, we plan 2 steps. The first, automatically update the system repositories, and second, collect data from other fake AQ source, and expand and better clean the corpus obtained from Wikipedia. Finally, before we release a production version of the system, we will continue improving the proposal and evaluating its performance. In addition, since the domain of this project is a sensitive topic related to public health, we need to carry out extensive tests that include assessments made with real users. Uh, Thank you.
Thank
Are there some questions?
Okay, thank you for the presentation. You don't have questions on the chat box, and let's get back to our chair. If there is any question, a comment, or concern.
No, I don't have any questions. Thank you so much for the presentation. Very interesting.
Okay, thank you. All the best, dear, in this important topic, even in, especially in this critical time. So now we wanted to finalize this session with the great thankfulness to everyone for the great presentation ideas and the brainstorming that the presentation led us to do, even without disclosing this, because it's really important ideas and match the needs in the market and the trends and technologies. So thank you for that. I sincerely thank our authors for their excellent presentations and contribution as a closure of our today in this session, and for sure all all of your participation improved and make this international conference happen. I hope it was informative enough to every one of you and raised many new ideas in your minds. So all of you will get their digital certification within a couple of business days. Further, the papers have already sent to Spring Earth, so they will be published hopefully 5 to 6 months. Your cooperation with our team would help to make it progress faster and faster. So thank you for your effort. The big thanks goes to our chair, Professor Verdi, for both the contribution and the helpful feedback. So thank you, Professor, for leading and chairing, being the chair of this session on behalf of WS4 2021 and the Global Technology Research Foundation. Thank you, sir. At the end of this session, I will ask every one of you to please keep their cameras on, even though it's virtual, but we still have a chance to make our memory. And hopefully next year we will meet physical with more contribution and have more fun and face-to-face chat without masks, without limitations, and everything will be great. So could you please just open your camera? I will count 3, 2, 1, then I will take the picture. So 3, 2, 1. Thank you, everyone. Okay, have a nice evening, and we hope to see you in our next session, which would be almost less than 1 hour from now. You already have the schedule. It would be by 4:30, almost 4:30. So then see you there, and thank you again for your time and contribution. Stay safe and have a nice rest of day. Thank you.
Thank you very much. Thank you. Bye.
Thank you. Bye-bye.
Thank you,
everybody.
Professor Bal.
Bye.
Thank you.
Bye.
Are you fine?